Hello, math fans. Dr. Andy Lovelace here. I'm teaching 3D calculus, and we're about to talk about contour maps. I find that some students find this topic challenging. To me, it's my favorite way to visualize a 3D surface. Often, it's better than looking at the 3D surface itself. If I'm standing next to a mountain, it might be hard for me to figure out how to hike around it. Now, any student that's been in my class and has looked at me probably says, has that guy ever hiked in his life? He's really out of shape. But here's an example of an elevation map or a contour map. I find that that's a pretty good visualization of a 3D object. I stole these from, this is actually from the REI website where they explain how to read maps. So let's grab that for a second. This is part of their explanation. You can go there. So there's REI can help you learn this class. They say, oh, look at the contours aren't very close together. And this is just for us to think about, and then I'll show you a few things. If the contours are close together, and what these are things that are at the same height. So what we do is we make equally spaced versions of these. Like in this case, it's every 100 feet. And so if you have from there to there, it's changed dramatically. 500 feet and just a few little bit, it's steep. So REI called it a cliff. Now it has a little bit of a slope. I don't know. It says this is a peak because you can see all the things kind of coming around it. Now to tell it's a peak, you need to know it's getting higher because then it's hard to tell the difference from a valley. And then it mentions if kind of the contours switch, you get lower one way, higher the other way. It's what they call a saddle. It's actually the same word we use in math. So I thought that was kind of interesting. So there you go. Go to the REI website to learn this. Here's another one I found on another hiking map website where they make one. This is actually part of like a test on a hiking map website. So you can see that it's getting higher and higher and higher. They call this a spur. We don't usually have that word. Things where it's close together means it's steeper. This is more than you need for this course. But I just thought this would be fun to go a little deeper than I usually do. You hear several examples. This is from yet another hiking website that says, here are some particular mountains you can see. In fact, you're going to have some sort of saddle point likely in there or in here. Okay, so I'm going to say a couple more things. I'm going to talk about Mount Saint Helens here in a second. But here is a contour map from an actual function that I made myself. And so I would hope that your eyes are drawn to something interesting's happening here. Something interesting's happening here. Maybe something interesting's happening over here and over here. It turns out these things over here are typically going to be saddle points. I'm just being casual here. And that'll be a saddle point, meaning a point that's at a place where the slope is 0 in a couple directions. But it's concave up and concave down, so we'll talk about that. These are typically going to correspond to max or min. So we can sort of see that. Now I didn't label anything, so we don't know if it's going up or down. Now I'm going to show you how I generated that. I think this will hopefully give you a little bit of an idea of what contour maps are about. Okay, so here we go. I generated it like this. I'm going to turn it. This is actually the ground. And now I'm going to show you where it came from. It came from this surface that I made right here. So that's kind of interesting. What did I do? I went up. So I'm going to show you something here. At each level, that's why we call these level curves, and you pick some equally spaced one. I just picked all of them. I can add a little more. At each one, I drew the curve that was there. And then I moved them all to the origin. Let's get rid of the surface. I feel like the surface is confusing me. So there's the surface and its level curves. And you can actually see the peak and the valley. Now I'm going to move them. Beautiful. There we go, moving them down all the way so that they sit on the XY plane. And there you can see, yes, One of them was a peak, this one over here. One of them was a valley, the one over there. And then you had these saddle points that we said were of interest. So I hope that's kind of interesting that you can see them. You can see those interesting points. Anyways, again, I'm exploring visuals I can make. So we'll finish this with a little quiz. Here is Mount Saint Helens. If you don't know this, a volcano in Washington that erupted in 1980. One of the last major eruptions on this planet. You might know something about it. And it was like midnight in the town I grew up in. I was born that year, the day that this happened. Here it is before it erupted. Kind of looked like a Rainier type mountain. And here you can see a somewhat clear peak here. Things are getting bigger as you go around. There's glaciers. This is a map. I found an article on this, and they had several U.S. Geological Survey maps from before. Okay, now let's look at what it looked like after. So here was after it erupted. You can see that the top is gone. And here is the new contour map. It's a little more modern, smoothed. But you can see there's some different behavior here. It doesn't just circle around. You get these weird little kind of loopy things here. And I know it's kind of hard to see, but the point is it doesn't look the same. There's a little depression in there that goes down. It comes up, it goes down. Very different than what we're seeing here. So that's more than you need to know. I will in a separate video actually show you how to make contour maps, but I thought it'd be interesting just to look at these because I think you've probably seen these before. And I think it's interesting to just think about how they actually give you a pretty good representation and might help you think about how you would hike around. All right, thanks for listening.